All right, so now hopefully you know how to name acids and bases, and you're ready to do the math work with it, right? Everything has math and chemistry most of the time. So let's get on to page 4. It's the bottom of page 4. So after you've done the work on the naming stuff, it says the Arrhenius concept. So let's take a look at this. So the Arrhenius concept of acids and bases, it was one of the first ones. We do two concepts. We do Arrhenius and we do Bronsted-Lowry. So the first one is Arrhenius, and this is most of our math. So acids are any chemical that produces H3O plus. Now, we said earlier they have an H plus on them. Well, if we have H plus and we add that to H2O, we end up getting, and this goes back and forth continuously, we end up getting H3O plus. And this is known as the hydronium ion. Some sources, if you're on the internet or if you're in a text, some sources they see it as H3O plus, and others we see with H plus. We will take it to mean that those are the same exact thing, because if you have an H plus and it's in an aqueous solution, you're going to have H3O plus. So to find the pH of a substance, you take the amount of, or the concentration, if you remember these brackets mean concentration of H3O plus, and you take the negative log of it. So if you've got your calculators, here is the log button. We'll take the negative log, and let's say we're dealing with HCl, the concentration of 1.5 molar. Well, since HCl is a strong acid, it gives up all of those H pluses to make H3O plus. So if it's 1.5 molar, we take that concentration of H3O plus to be 1.5. So we take the negative log of 1.5, and you can see that is negative 0.176. That is very highly concentrated HCl, right? The pH is well below 7. Let's say you have a weak concentration of HCl, 1.5 times 10 to the negative fourth. But then you have a pH of about 3.8. Now with pH, we do go out 2 decimal places. It's a set thing, just like our percentages. So keep that in mind. Just go out 2 decimal places. So 3.82 is what our answer would be. The reason for that is the rules for significant digits in log are different than the rules for significant digits multiplication, division, addition, subtraction. So the strong acid, if you know it's one of those 6 strong acids, you use just negative log and boom, done. That's how you find the pH. If it's a weak acid, it's a little bit different. So if we take a look, for all practical purposes, if the concentration is prepared, we know this as the molarity of the acid. So for those 6 acids we have memorized from the first page, we just plop in that concentration, we take the negative log of it. The exception of that is sulfuric acid. Since it is diprotic, whatever the concentration of that H2SO4 is, we then multiply it by 2. And then we take the negative log of it. And that's the fact because it has 2 hydrogens on there. For the weak acids, it's a little bit different. An acid where only a fraction of the molecules undergo ionization, for such acids, it's safe to say that H3O is less than the prepared concentration. So if we were to have, let's say, our acid, we'll just call that HA. Whenever it goes here, we get H plus, which makes the H3O plus, and the A negative. Whatever the A is, that could be Cl, that could be F, or that could be like NO2 or something like that. Basically, what we do is we make what's called the constant of the acid. Products go on top, reactants go on bottom. So basically the top will be equal as long as there's only one H. So we will call that, if this is x, then this is x squared. And I'm just going to put that concentration of x and then square that. And this is all over the concentration of the acid, which I'm going to change to be the molarity of the acid. So if I want to solve for x, which is that H plus concentration, we're going to multiply both sides by ma, or molarity of the acid, and that will cancel this out. And then we have x squared, so in order to get rid of that squared, we need to take the square root of this whole thing. So that concentration of H3O plus is equal to the square root of comma, or ma-ka, however you want to do it. And that's for a weak acid. That's for if you're looking at it and it's not one of those 6 strong acids that we had from the notes. Keep that in mind. The same thing occurs for the bases. There's something called the pOH, and basically that's just a log function of the hydroxide ion concentrations. So that's negative log of, for a strong base, the hydroxide, whatever the concentration of the base is, or the molarity of the base, it's the negative log of that. And just as we have this for the acids, it's the same thing. Basically, you would put that through, and if it's one of those weak bases, one of the ones that's not the 5, then you put the molarity of the base here, and you will be given the acid constant or the base constant if you're asked to do this. So they will give you that acid or base constant, and basically you multiply the molarity of it by the constant, and then you square root it, and that gives you the concentration of the hydroxide. Now, if you want the pOH or the pH, and you have the concentration then of the hydroxide or the hydronium ion, you still need to take that negative log of it, or the negative log of the hydroxide ion concentration. Now, what will help you do this are these equations that are found on this page right here. So if we take a look, the pH of something